Hello, and this time I'm talking about surds. And a surd is simply a square root that hasn't been worked out. So just like sometimes we leave the answer as a half rather than saying 0.5, which isn't so much of an advantage because that's a nice decimal, nice fraction. But for example, 1/3 we leave in the answer because that's better than having to write 0.3333, yes, or having to write 0.3 recurring. And certainly saying 1/7 is much better than having to write out the many digits. And then even if you wanted to write it with recurring, if you want to be accurate, 100% accurate, you'd have to write out the sort of 5 or 6 digits that make up the recurring pattern. So leaving things in fractional form is more accurate because you don't have to do any rounding or writing out all these sort of recurring things. And there are some numbers that do the same thing, like root 2 will have a big long decimal, and you can't even do recurring for that one. Root 2 never repeats itself. So there isn't a nice way to write it out in a decimal 100% accurately. The only way to do it, although it stops here for the calculator, it's just because it hasn't got any more display left, but this will just go on forever, being various numbers all the way to infinity. It won't ever settle into a nice repeating recurring pattern. So the only way to write root 2 accurately is to leave it in its square root as root 2, and then when you need to know the actual number because you're cutting a piece of wood or something like that, well, then you can work it out at the end and turn it into decimal so you can measure and cut. But if you want an accurate answer, you've got to leave it as root 2, and that's all a surd is. And then, just like we can cancel down fractions, so if we have something like 12/20, then you'll look at that and say, well, that's fine, but it would be better if it was 6/10, wouldn't it? Well, actually, I can divide that again and say it's 3/5, and that's a better way of saying the fraction than the 12/20 because the numbers are smaller and easier for us to process. It's easier to imagine a piece of wood in five pieces and I'm having 3 of them than to imagine it in 20 pieces and I'm getting 12 of them. And we can do the exact same thing with square roots, with surds, but it's just a bit different because, of course, when we cancel down the fraction, we said what number divides into both. There's 2 numbers, and we need to divide both of them by the same amount. But here we haven't got 2 numbers, but we have got a square root. So to cancel these down, we're going to be saying, are there any square numbers that go into this? And the reason we're looking for square numbers is because a square number can be square rooted. If I've got the surd root 4, well, there's no point leaving it as a root 4. I can just write 2, because that's what the square root of it is. And just like if you had, 7/1, you don't leave it as 7/1, you just write 7. So what we're trying to do in these is we're trying to find square numbers. And why is that helpful? Well, because with square roots, you can split a number into times, and then you can make it 2 timeses together. So what do I mean? I mean, if you've got root 6, then this is the same as the square root of 2 times 3. Well, yeah, that makes sense because 6 is 2 times 3. And this is the magic bit, that this we can split the square root and say that root 2 times root 3, we can do that. We can't do it with an add. So with Pythagoras, you've got like 5 squared plus 10 squared. You can't split that into root 5 squared plus root 10 squared. That's not allowed. No, no, no. But with timesing, you are allowed to do it. You're allowed to split these into 2 separate ones. So we can do that, and if this isn't helpful though, because neither of these is going to make a square number, we can't simplify either of these down anymore. But with root 75, then we can split it, and what we want to do is split it into a square number and something else. And in this case, root 75, we could say is 25 times 3. And then we can split that in our magic way into 2 separate roots, and we know that root 25, well, that's 5. That's easy to do because it's a square number. And the root 3 I can't simplify, but at least what I've managed to do is turn a root of 75, which is a big square root number, a big number in the square root, into a little number in the square root, and then a normal 5 that's absolutely fine. I can deal with that 5 quite nicely. Let's do it with the 45 as well. So root 45, we need to think of a square number. So the square numbers 1, 4, 9, 16, 25, 36, etc. Any of these will go in. Well, 1 will, but that's not going to cancel it down any helpfully way. So 4 doesn't go in, but 9 goes in. 9 goes in 5 times. So we can put this as root 9 times 5, which is root 9 times root 5, which is, we can do this square root, 3 root 5. Now, you don't need to write all of this down. You might feel that you're comfortable going straight from this thing to this. It might be that you feel comfortable going straight to that one, but I wouldn't recommend that, because if you have this in an exam and you just write down the answer, they won't give you any marks. They need to see an intermediate working out stage so they can see you know how it works. Because, of course, your calculator, if it's relatively modern, will do this for you. So you can check these ones. As long as they don't have algebra in, you can check them. 5 root 3, that's what we had. And if we change that to a 45, then we get 3 root 5. So we got them right, and you can check them like that. Your calculator will always give the surd in its simplest form. So it's a good way of checking it on your calculator. Okay, so let's have a look at these ones. Can we simplify these? Well, yeah, we can, because we've got, this one's quite nice, this first one. The 3 and the 5 are not square roots, they're just numbers. So we're just going to times those together. It's like saying 3x times 5y, yeah? These are just numbers, 3 times 5. So 3 times 5 is 15. And now look at this, root 2 times root 2. Well, if you times together the same root, then they're going to cancel out, yes? Root 2 times root 2 is like root 2 squared, and squared and square root cancel. The other way to look at it is root 2 times root 2 is root of 2 times 2, and that is root of 4, which is 2. So whenever you times the same root by itself, a root by itself, then you just get rid of the root. So this is just a 2, and this is times 2, so the answer is 30. Now that was nice because the roots were the same, but that's not always the case. And in this last example, we've got root 3 and root 7. So let's do that. 4 times 3 is 12, and then we've got root of 7 times 3. We can put them together. So this is 12 root 21. Now sometimes this 21 will have other factors, and you can then divide it by a square number. But 1, 4, 9, 16, none of those are going to divide in other than 1, which isn't helpful. So actually that's as simple as we're going to get on that one. We can't divide it by 4 or by 9, so no, that's as simple as we're going to get. But there are times when you do multiply them together and you get something that can simplify down in a different way. For example, root 3 times root 6. So you can't simplify root 3 and you can't simplify root 6, but when you put them together, 3 times 6 is 18. Well, we can simplify this down because this will divide by 9. This is root 9 times 2, and 9 is a square, so this is 3 root 2. It square roots as it comes out of the root. So we had two different surds here, neither of which would cancel, but by timesing them together, we get a number that will then split down into a different way, okay? Because 18 has factors of 3 and 6, which doesn't include a square number, but it has factors as well of 2 and 9, one of which is a square number. So we can write it in a really nice, easy way. Now, there are lots of other things you can do with surds, like rationalizing denominators and things like this, but I'm going to leave those for another video and just stop at this point where we've talked about what a surd is and how we can cancel down surds and how we can combine surds together and possibly cancel them down as well. So if you have any questions or comments about that, then pop them down in the comments below. Otherwise, cheerio.